Module 6.1, solving for and recognizing congruent angles, vertical angles, and what we so-call the adjacent angles. So I mentioned the word adjacent angle before. Adjacent angle means it's a straight line. If I go back to my angles, okay. So adjacent angles, or think of a straight line, okay, is always 180 degrees, okay. So let's do some application involving with congruent, vertical, and adjacent angles. All right, so quickly, two lines. We know two lines can intersect, all right, if they have exactly 1 point in common. So from the previous video, we also see two lines don't have to intersect if they are parallel. But if they do intersect, they will only intersecting at one common point. So whenever we see two lines intersecting at one common point, okay, then the two pairs of what we so-called the vertical angles are formed. Vertical angles are opposite to each other, okay? Opposite are located. Maybe the better wording here is are located opposite from each other or to each other. So that means this angle on the left, angle 2, actually sit opposite. You know, I don't like to use the word opposite. I like to say facing. Angle 2 is facing angle 3. Okay, so we consider angle 2 and 3 vertical angles. All right, so vertical angles are angles facing each other. Okay. But what got to happen first is you got to see two lines intersecting at one point. So if I would say angle 2 is 60 degree, okay, then angle 3 will also be 60 degree. And we say vertical angles are always congruent. Okay, congruent means same angle measurement for angles. So that means angle 1 got to be the same as angle 4, but what is going to be angle 1? All right, two lines intersecting at one point. If I pretend to say angle 2 is 60, and angle 2 faces angle 3, so angle 3 will be 60 because vertical angles are always congruent. But what will angle 1 be? Because if I know angle 1, I also know angle 4 as well. So what will angle 1 be? Well, the way how we think about this is let's pretend angle 3 does not even exist. All right. So what you see here is angle 1 and 2 is sitting on the same, it's actually sitting on the same straight line. All right. It touches angle 1 and 4 touches the same two lines, basically. All right, in that case, when they're touching the same two lines, in that case, I would say angle 1 and 2 is sitting on the same line. So on the same line, it got to be 180 degree. So since angle 2 is already 60, then angle 1 got to be 120 degree because the two angles together are 180. I'm not saying the two angles are complement. I'm just saying all angles sitting on the same straight line got to be 180 degree, okay? And that's why we call them adjacent angles. They are sitting right next to each other, but they are sitting right next to each other on the same line. It touches the same lines, okay? So therefore, they will be exactly 180 degree. So now, if I will bring my another line back, angle 1 faces angle 4, so angle 4 will also be 120 degree. It's not a perfect example, you know, but I should have 120 here on the as a red one, and purple one should be 60, because I didn't quite get my numbers right. All right, so angles facing each other. When you see two lines intersecting at one point, the angle they are facing each other, okay, are called the vertical angles. Vertical angles are always congruent. So here we see two lines intersecting at one point. So we begin to think about the concept of vertical angles. If measure of angle 2 So the problem telling me angle 2 here is 75.9 degree. What is the measure of angle 4? So angle 4 is right across from angle 2. So angle 4 got to be exactly the same because they are vertical angles. All right, name one pair of vertical angles. Name just one pair. So you can say, well, angle 2 and 4 are vertical angles because they are sitting right next to each other. Not sitting right next to each other, sitting across from each other, or they face each other. Or you can say angle 1 faces angle 3. So those two are also vertical angles. Just name one pair. All right, name one pair of adjacent angles. That means the angle sitting side to side. So as long as they touch the same line, okay, they're considered as adjacent angle, or it forms a straight line, or it's 180 degree. So if you look at angle 1 is sitting right next to angle 4. So these two angles on the same line, okay, so they are adjacent angles. So I can say 1 and 4. That's one pair. All right, what else? I can also go back and say, well, angle 1 right here is actually right next to angle 2 because the two angles sitting on is touching the same line. So 1 and 2 can be a pair. Or I can say 2 and 3 is on the same straight line. Or I can say 3 and 4 is on the same straight line. Okay, so I can name different pairs as long as they're right next to each other. Okay, all I need to do is name one pair. 1, 4, 1, 2. Okay, 2, 3, and the bottom 3 and 4. Okay, you just got to name one pair of them. So here I basically have 4 pairs of adjacent angles. I just need to name one of them. All right. So this concept, a transversal, what is so-called a transversal, is referring to a line in the plane that will intersect 2 or more lines in the in the same plane at the different points. 8 angles are actually formed when the transversal intersecting 2 lines. All right. So here I got line 1 and line L and line M. So this letter T is referring to transversal. All right. So when the transversal is intersecting with these 2 lines, 8 angles are actually formed. But let me kind of go ahead and tell you this right away. If I will say line L is parallel with line M, all right, then when these 8 angles are formed, okay, they can be named as follow. Something called the corresponding angles, alternate interior angles, and something called the interior angles. Okay, so corresponding angles are referring to angles sitting at a similar position between the 2 line L and line M compared to transversal T. So if you look at angle 2, angle 2 is above L to the right side of T. So another angle that is similar to that position is angle 6, which is also to the right of transversal, but this time it's sitting above, all right, sitting above line M. All right, so 2 and 6 are corresponding. All right, 1 and 5 are also corresponding because these two are at a similar position between the 2 lines, L and M. All right, so 3 and 7 are at a similar position. So is 4 and 8. So corresponding angles are angles sitting at the similar position between the 2 lines and as compared to transversal. All right. So if line L and line M are parallel, then the corresponding angles are always congruent. Okay, so that means 2 and 6 are exactly the same angle measure. 3 and 7 are the same. 1 and 5 are the same. 4 and 8 are the same. All right. Now, this thing called the alternate interior angles. The word interior is referring to in between the two parallel lines. Because if I will go ahead and say L and M are parallel, then the word interior means in between. Alternate means alternating side. So, excuse me, alternate interior angle here is referring to angle 3 and angle 5. Okay. And it's also referring to angle 4 and angle 6. Well, Mr. Chen, why don't we say 3 and 4 are called the alternate interior angles? Well, because the 3 and 4 are actually considered as adjacent angles because they're touching the same exact lines. So that means these two angles are together equal to 180. So what we so-called the alternate interior angle, sorry about that, what we so-called the alternate interior angle, they will always be congruent. So that means 3 and 5 are the same. Angle 4 and 6 are the same. Alternate interior angles in between the two parallel lines and alternating side. So they kind of sit diagonally from each other in between the two parallel lines. What is so-called the interior angles? Okay, that means between the parallel line and also on the same side of the transversal. So interior angles on the same side of transversal, that will be 3 and 6. And the other pair is 4 and 5. They are between the two parallel lines on the same side of transversal. Okay? And interior angles always have the sum of 180 degrees. So that means angle 3 plus angle 6 will equal to 180. All right, angle 4 plus angle 5 will also be 180. All right, that's called the interior angles. All right, and all these three things got to be true if we know line L and line M are parallel. So this is actually part of what we so-called the properties of parallel lines. There are other properties of parallel lines, but this is just 3 of them. Okay, something called the corresponding alternate interior and interior angles. All right, let's take a look. Okay, let's take a look. The following figure shows 3 intersecting straight lines. So this time I got 3 intersecting straight lines. Okay. Angle 1 is at 42 degrees. So, okay, this example does not have parallel lines. So we are not even thinking about this right here. All right, we're not even thinking about something called corresponding alternate interior or interior angles. We will do more of these type of problem in our Math 168 geometries and trigonometry course. Okay, but this time, this particular example shows 3 intersecting lines at one point. Find the measure of angle 4. So right now I know angle 6 is a 90 degree because the marking, and it also tells me, and angle 1 is 42 degrees. So angle 1 is right here, and that's 42. So if you look directly across from it, angle 1 faces angle 4. So that's called the vertical angle. So angle 4 got to be 42 degrees. So right away, I know angle 4 is 42 degrees. You know what? I'm going to go ahead and figure this out, okay? Find the measure of angle 2. Well, angle 2 is a little bit trickier because you got to think 2, 1, and 6 actually touches the same exact lines. Okay, they're all sitting on They all kind of sit on line X right here. All right. And angle 2 touches Y and X. Angle 1 touches Y and Z. Angle 6 touches X and Z. So all three angles together, sitting on the, coming off the same line X and touches the same Y and Z. That means all three of them together got to equal to 180 degrees. So if I know 6 is already 90, that means 1 and 2 together got to be 90 minus, all right, 1 and 2 together 90. Part of it is 42, so the missing one, angle 2, got to be 90 minus 42 degrees. And it's very important that we use the total 90 between 1 and 2, subtract off part of the 90 degree, okay? Because that same 90 degree is actually being split up. 1 is 42, so the missing one got to be 90 minus 42. It's a very important concept using that subtraction. To find the missing one, knowing the total, and to find the missing one, if I know 1, then I can find the other one, which is 48 degrees. All right. Which two angles are complementary to angle 4? Oh, let me write 48 right here real quick. Okay. If angle 2 is 48, that means angle 5 is also 48. So think about this. 42 and 48 together is going to be 90 degrees. And the word complementary are referring to two angles that have a sum of 90. So who are complement to angle 4? Well, angle 4 and 5 are complement to each other because they add up to be 90. So that's angle 5. Now, since angle 4 is the same as angle 1, and angle 1 is complement with angle 2, because together, these two together is equal to 90 degrees. So that means angle 4 is also complement with angle 2 because they got same angle measurement. So if angle 4 is complement with angle 5, which is 48, it also got to be complement with angle 2 as well. All right. So that's how we actually use right angles, two lines that are perpendicular, the concept of complementary, okay, to solve this problem, along with our idea of vertical angles. All right. So that will conclude this lecture video. Thank you for watching.